Good evening, students. Next, aldehydes and ketones reduction process. Aldehydes are reduced to primary alcohol and ketones are reduced to secondary alcohol by using sodium borohydride NaBH4 or lithium aluminum hydride LiAlH4. This concept actually we have completed from the lesson alcohols, phenols and ethers. So here the main reaction is aldehydes are reduced to primary alcohol. Ketones are reduced to a secondary alcohol. Next is reduction to hydrocarbons. Actually, this area is very important because two main reactions are coming here. It's very important for your board examination. One main reaction is Clemenson's reduction. Another reduction is Wolff-Kishner reduction. So first, let us discuss about the reduction to hydrocarbons by Clemenson reduction. So the main reaction is, I will explain. The carbonyl group of the aldehydes and ketones are reduced to CH2 group on treatment with the zinc amalgam and concentrated HCl. So this is the reaction. So either an aldehyde or a ketone contains this group. The CO group of the aldehyde and ketone on treatment with the zinc amalgam and concentrated HCl. What happens is the CO group is reduced to CH2 group plus water. Actually, this is a name reaction called Clemenson's reduction. Clemenson reduction. So please write it and study. Next, the same reduction only in Wolff-Kishner reduction. Actually, the change is instead of this zinc amalgam and concentrated HCl, we have to use hydrazine followed by treatment with the potassium hydroxide in a high boiling solvent like ethylene glycol. Let's write the equation once again. Wolff-Kishner reduction. Okay. So Wolff-Kishner reduction. So aldehydes and ketones contains this CO group. So this compound should be treated with the NH2NH2. NH2NH2 means hydrazine. This hydrazine followed by treatment with the potassium hydroxide in high boiling solvent like ethylene glycol. So that also should be written below the arrow. KOH, ethylene glycol. So this is a reaction. So two name reactions are coming this side. One is Clemenson's reduction and another is Wolff-Kishner reduction. So once again, let me explain. In Clemenson's reduction, the CO group present in the aldehyde or ketone are reduced to CH2 group by treatment with the zinc amalgam and concentrated HCl. So this compound plus water is formed. Another reaction is Wolff-Kishner reduction. Here the only difference is the reagents are changing here. Like the keto group or the aldehyde group, that particular compound should be treated with the NH2NH2. That is hydrazine followed by treatment with the potassium hydroxide in high boiling solvent like ethylene glycol. An alkene is formed followed by treatment with the followed by nitrogen gas. Next, oxidation. We have already learned that aldehydes are more reactive than ketones. So, when aldehydes are oxidized, in presence, for example, by treatment with nitric acid, potassium permanganate, then potassium dichromate, even mild oxidizing agent like Tollens reagent. Tollens reagent is ammoniacal silver nitrate solution. What is Tollens reagent? More questions has been asked so many times. Tollens reagent is ammoniacal silver nitrate solution. These are the filling solution, etc. So what happens is aldehydes are oxidized to the corresponding carboxylic acids. So we have studied Tollens reagent is ammoniacal silver nitrate solution. And another thing to be noted here is what is filling solution. Filling solution is actually there are when we talk about filling solution A and filling solution B. Actually, we have to take an equal volume of filling solution A and filling solution B. So filling solution A means an aqueous solution of copper sulfate. That is filling solution A. Filling solution B means an aqueous, uh, an alkaline solution of sodium potassium tartrate, which you call it as Rochely salt. So an equal volume of filling solution A and filling solution B should be mixed. Then only that particular reaction will happen. So once again, let me tell you, in oxidation reaction, aldehydes are oxidized to the corresponding carboxylic acids. Even using mild oxidizing agent like a Tollens reagent or filling solution or nitric acid, potassium permanganate solution, potassium dichromate solution, etc. So let's write the equation. RCHO oxidized to RCOOH. So this is the equation. RCHO, aldehydes. What is O in brackets? That is nascent oxygen. Oxygen at the moment of its formation. RCHO is directly changing to RCOOH. So this is about the oxidation of aldehydes. Then let's see about ketones. Actually, ketones are oxidized under vigorous conditions. Vigorous condition means strong oxidizing agents should be used. Then elevated temperatures means particular temperature has to be used. Actually, what happens is the cleavage of CC bond happens. Cleavage means breaking of the CC bonds happens to form a mixture of carboxylic acids having lesser number of carbon atoms. That is very, very important. So cleavage of CC bond happens and a mixture of carboxylic acids are formed, but that's a speciality that having lesser number of carbon atoms than the parent ketone. That is a reaction. So let's write the equation. CH2 CO CH2 R dash. Now consider this ketone R CH2 CO CH2 R dash. Now let's number this compound like one first carbon, second carbon, and third carbon. Now I have put a number: carbon number 1, carbon number 2, and carbon number 3. Okay. Now oxidation process happens. Now the first product is RCOOH plus R dash CH2 COOH plus R CH2 COOH plus R dash COOH. So this is a product form R COOH plus R dash CH2 COOH and R CH2 COOH and R dash COOH. Actually, here I put numbers 1, 2, 3. So actually this mixture of carboxylic acids are formed by the cleavage between carbon number 1 and carbon number 2. Here RCH2COOH and R dash COOH. This mixture is obtained by the cleavage of carbon number 2 and carbon number 3. So let me mark that. So please go through this equation. RCH2CO RCH2CO CH2 R dash undergoing oxidation, nascent oxygen. We are getting a mixture of carboxylic acids. That is, this happens between the these products are obtained by the cleavage of CC bonds. Next, mild oxidizing agents given below are oxidized. Then how to distinguish between an aldehyde and a keton? This is also very important as far as the board exams are concerned. How can you distinguish between an aldehyde and a keton? As I told you before, Tollens reagent means ammoniacal silver nitrate solution. Actually, we are going to do this experiment when you are going to analyze the organic compounds. Aldehydes on treatment with a Tollens reagent, or an aldehydes are warmed with the Tollens reagent with the freshly prepared ammoniacal silver nitrate solution. Freshly prepared means at the moment of its formation. A bright silver mirror is obtained. That is a reaction. A bright silver mirror is obtained. Aldehydes are oxidized to the corresponding carboxylate anion plus silver. So let me write the equation. Tollens test. Actually, you should. The equation is little bit seems to be complicated, but no complication. But to write and study. RCHO. Okay, that is the aldehyde. On warming with the freshly prepared Tollens reagent, ammoniacal silver nitrate solution. So the presence of OH minus is there. Obviously, we are getting a silver mirror, and aldehydes are changing to the carboxylate anion. Next, filling solution test. Fillings test. Let me write the equation first. RCHO plus 2Cu2 plus 5OH minus is RCOO minus plus CO2O plus 3H2. Okay, filling solution as I told you before. Filling solution comprises of filling solution A and filling solution B. Filling solution A means aqueous copper sulfate solution, and filling solution B means sodium potassium tartrate or Rochely salt. Okay, so in the alkaline medium actually. Okay, these solutions are mixed in equal proportions. On heating aldehyde with a saline solution, a reddish brown precipitate is obtained. So please go through this equation. RCHO plus 2Cu2 plus 5OH minus gives a carboxylate anion plus Cu2O. That is a brown precipitate plus 3H2O plus 4NH3. 3H2O. So these two reactions are very, very important. And, next, another important reaction, oxidation of methyl ketones. This is also very, very important. Oxidation of methyl ketones. By haloform reaction. Oxidation of methyl ketones by haloform reaction. Aldehydes and ketones having at least one methyl group. Methyl group we know CH3. So aldehydes and ketones having at least one methyl group linked to the carbonyl carbon atom or methyl ketones are oxidized by sodium hypohalate. Sodium hypohalate NaOX, where X can be chlorine, NaOCl, Na2 sodium salts of corresponding carboxylic acids having one carbon atom less than the carbonyl compound. This is the haloform reaction actually. This is very, very important for the exam point of view. The oxidation does not affect the carbon-carbon double bond actually if present in the molecule. Let me write the equation. RCOCH2 in presence of sodium hypohalate NaOX gives RCOONa plus CHX3. This X can be chlorine, bromine or iodine. So please go through this equation. RCOCH3. RCOCH3. When treatment with the sodium hypohalate NaOX, it forms the sodium salt of the corresponding carboxylic acid plus CHX3. For example, if in place of X, if you are using Cl, the product will be RCOONa plus CHCl3. CHCl3 is chlorophyll. So let me explain this reaction once again. Aldehydes and ketones having at least one methyl group linked to the carbonyl carbon atom or methyl ketones. They are oxidized by sodium hypohalate NaOX. X can be chlorine, bromine or iodine to the sodium salt of the corresponding carboxylic acid. But there is a peculiarity for that particular compound. Having that particular compound, it will be having one carbon atom less than the carbonyl compound. So this iodoform reaction with the sodium hypohalate is used for the detection of CH3CO group or CH3CHOH group, which produces CH3CO group on oxidation. So all these reactions are important. Now there are some homeworks which you have to do in NCERT textbook. Example 12.3. Which one is more reactive, benzaldehyde or propanol? Please write it in your classwork. Then one example is given 12.4. Question and answer both are given. Please read the question well and go through the answers. In case of any doubt, please clarify with me. Once again, I am telling, simply don't read the textbook while studying. You should read and write. That should happen simultaneously. Okay. Thank you.